Welcome back to the deep dive. All right, settle in, maybe grab that last coffee or something stronger. Because tonight we are really jumping into the deep end. We're tackling that huge, nagging question, the Fermi paradox.
The big silence.
Yeah,
It's where the math just doesn't match reality, right?
exactly. The universe should be noisy, teeming with signals, civilizations. Statistically, it makes sense. But we listen, and nothing, just static.
Crickets, cosmic crickets. And it's not like we haven't been looking.
Mm-hmm.
Decades of searching, and the silence just gets, well, louder, paradoxical.
Totally. And look, we all know the usual suspects for why. The great filter, maybe they all blow themselves up. Or, the dark forest idea, stay quiet or get zapped.
Right, the classic hits. Fun, but maybe a bit straightforward.
Yeah, we wanted to go weirder tonight. Based on our reading, there are these other explanations bubbling up, ideas from physicists, futurists, stuff that sounds like straight-up high-concept sci-fi, but people are actually debating it seriously.
Ideas that kind of flip the whole thing on its head. Maybe the silence isn't failure. Maybe it's success. Or something so different we can't even recognize it.
Okay, so you're definitely going to want to stick around for this. We're talking about civilizations ditching expansion to, merge with black holes for better Wi-Fi, essentially, the transcension hypothesis.
Or the unsettling possibility that discovering quantum immortality, this idea you can't really die across the multiverse, actually makes civilizations more likely to wipe themselves out in most realities, including ours.
Yeah, that one's a mind bender. And then there's the idea that maybe they're just too advanced. Like, their tech is so far beyond us, it just looks like noise, random space stuff. Cosmic background radiation could be their group chat.
Or maybe they've gone full Zen and merged with the universe's background frequencies. So, yeah, it gets properly weird. Strap in.
All right, let's kick off with this first big theme, the Great Retreat. This whole category suggests advanced civilizations don't fail, they just opt out. They choose invisibility.
Yeah, it's the idea that once you get sufficiently advanced, think Kardashev Type 2, Type 3, manipulating stars, galaxy, maybe galactic conquest looks kind of inefficient.
Yeah.
Clunky, even.
Like, why bother terraforming Mars when you can build a perfect simulation?
Exactly. Or maybe just optimizing what you already have becomes the main goal. It's like a phase transition. You hit a point where expanding outward costs more energy and resources than perfecting your inner world or your computational efficiency.
So the drive shifts from conquering space to mastering inner space or information space.
Precisely. It assumes intelligence ultimately values things like efficiency, longevity, maybe even subjective experience over just, planting flags on more rocks.
Okay, and the most out there version of this inward turn has to be the transcension hypothesis. This is the one that really grabbed me from our reading.
Oh yeah, John Smart's idea primarily.
Yeah.
It suggests that really advanced intelligence, probably post-biological uploaded minds, vast AIs, that sort of thing, they don't spread out, they compress inward.
Inward. How?
Compressing STEM space, time, energy, matter. Shoving it all down into these incredibly dense, hyper-efficient computational states. It's the ultimate optimization.
So where do they go?
The best place for density and computation. Black holes. Or maybe artificial singularities they create themselves. They essentially migrate their entire civilization to the edge of, or maybe even into, these regions.
Wait, why a black hole? That sounds kind of terrifying and destructive.
From our perspective, sure. But think about it purely from physics and information. Two huge reasons. First, information density. There's this thing called the Bekenstein bound.
Okay.
It's basically the absolute maximum amount of information you can possibly pack into a given volume of space with a given amount of energy, like the universe's hard drive limit. And guess what achieves that limit naturally?
Black holes.
Black holes. They're the most information-dense things we know of. So if your entire civilization is about processing information, running simulations, achieving computational nirvana, a black hole is the ultimate real estate. Maximum storage, maximum processing potential per cubic centimeter.
Huh. Okay, that's weirdly logical. Maximum bang for your computational buck. What's the second reason?
Time dilation. This is the wild part. Get close to a massive gravitational well like a black hole, and time slows down for you relative to the outside universe.
Right, like an interstellar.
Exactly. So for these beings living near the event horizon, maybe only a few years pass for the rest of the universe, but subjectively, they could experience billions, trillions of years. They basically hack subjective eternity.
Woo! So they achieve this perfect digital life and stretch it out forever, all while the rest of us are just waiting a cosmic second for them to blink.
Pretty much. They could live out countless eons of computational utopia in what seems like a short time to us. So the silence we hear, it's not because they're dead. It's because they've voluntarily checked out into their own private, hyper-efficient, time-dilated heaven.
So we're shouting hello into the void, and they're potentially living these vast billion-year simulated lives between our syllables. Humbling and kind of sad, maybe.
Well, yeah, but there's a big if here, right? The huge assumption is that all advanced life inevitably cares most about computation. Is that really universal? Or is it just us projecting our current tech obsessions onto the cosmos?
Good point. Maybe some aliens just like, hiking or exploring actual planets.
Exactly. It's an anthropocentric bias, potentially. Plus, it's almost impossible to test. You can't exactly ping a black hole and ask if it's running sentient software.
Maybe look for weird gravitational waves or like oddly specific Hawking radiation patterns, a black hole emitting perfect sine waves or something.
Maybe. That's the kind of indirect signature you'd have to look for. Extremely subtle, probably looks like noise until you know exactly what pattern means. We're in here, leave us alone.
Okay, so if compressing inwards near black holes is one path to efficiency, another idea from our reading is basically moving out, way out, to get better cooling, intergalactic heat dissipation.
Yeah, this one's grounded in good old thermodynamics, specifically Carnot's theorem.
Claim.
Basically, the efficiency of any heat engine and computation is a kind of heat engine. It produces waste. Heat depends on the temperature difference between its hot part and its cold reservoir, the environment it dumps heat into. The colder the environment, the more efficient the process.
Okay, makes sense. Less energy wasted as heat means more useful computation per joule.
Exactly. Now think about running truly massive computations like planet scale or even star system scale computers. The amount of waste heat would be astronomical. It becomes the ultimate bottleneck.
So you need the ultimate heat sink, the ultimate air conditioning.
Right. And where's the absolute coldest place you can find?
Deep space.
Even colder. Not in a galaxy like ours. Galaxies are actually kind of warm, relatively speaking. All those stars, dust clouds.
Yeah.
The average temperature in interstellar space within the Milky Way is maybe around 15 Kelvin, 15 degrees above absolute zero.
Okay, so where's colder?
The voids. The massive, almost completely empty regions between the galactic filaments and clusters. Out there, the temperature is basically just the cosmic microwave background radiation temperature, about 2.7 Kelvin.
Whoa, that's a big difference. 15K versus 2.7K.
Huge. It means you could run your computations potentially 5, maybe 10 times more efficiently just by relocating your server farm to an intergalactic void.
So the theory is, advanced civilizations literally pack up their entire operation, maybe upload themselves, build these massive computing structures, and just move out into the empty blackness between galaxies.
That's the idea. It explains the silence as a strategic move for thermodynamic optimization. They aren't dead, they're just off the grid, living in the cosmic equivalent of Siberia because the rent, in terms of waste heat, is cheaper. They're dark nomads.
Wow. Imagine deciding to move your whole civilization just to lower your cooling bill. That's a commitment to efficiency.
It really reframes the search, doesn't it? We're looking for bright lights in galaxies near stars. Maybe we should be looking for, I don't know, suspiciously ordered concentrations of mass or weird thermal signatures in the voids, where we currently see almost nothing.
Hunting for dark structures in the dark, that's a challenge, but a fascinating one. They might be hiding in plain sight, just in the places we barely look.
And following that thread of long-term thinking and efficiency, there's the estivation hypothesis.
Estivation, like hibernation, but for heat.
Kinda, yeah. But on a cosmic timescale. If computation gets more efficient as the universe cools down, and the universe is going to keep cooling down for trillions upon trillions of years.
Then why do all the heavy lifting now?
Exactly. Why run your super expensive, energy-intensive simulations today when you could wait, say, 1 trillion years when the background temperature is near absolute zero and do it for a tiny fraction of the energy cost?
So they just go to sleep for potentially trillions of years, set the cosmic alarm clock for the deep future.
That's the core idea, the great nap. They enter a state of extreme low activity, conserving every possible erg of energy, waiting for the universe to reach optimal conditions for maximum computation. The silence is just strategic dormancy.
Ultimate patience. Wow. And related to that is the idea of virtual isolation, right? If you're not waiting for the cold, maybe you've just built your own perfect world already.
Right, the advanced matrix scenario. If you can create a simulated reality that provides perfect fulfillment, subjective immortality, anything you could ever want,
Right.
why bother with the physical universe at all?
It's messy, dangerous, expensive.
Exactly. If ultimate satisfaction can be achieved internally within a simulation, then physical expansion, space travel, dealing with annoying things like physics and entropy. It just seems pointless. They retreat inward into virtual worlds.
So both estivation and virtual isolation lead to the same outcome for us, silence. Either they're asleep, waiting for better processing weather, or they're awake but plugged into their own private digital heavens, totally ignoring the outside world.
Yeah, the common theme is a deliberate disengagement from the physical cosmos, either strategically delaying engagement or abandoning it altogether for something better internally.
It makes you wonder, doesn't it? Our own growing obsession with virtual reality, social media, digital worlds is like the very, very first baby step towards this kind of ultimate retreat.
It's a provocative thought.
Yeah.
Is that drive for physical exploration and expansion actually a sign of, well, immaturity? And the truly advanced life just chills out, either literally chilling for the cold future or figuratively chilling in VR.
Food for thought. Okay, let's shift gears. So if that first set of ideas was about aliens choosing silence, this next batch is maybe more unsettling. It's about fundamental limits, barriers rooted in physics or cognition that might force silence or at least make detection impossible for us.
Right. We're moving from deliberate invisibility to maybe existential roadblocks, things that prevent contact not because they want to hide, but because the universe or their own nature just works that way.
Yeah.
Quantum weirdness, cognitive gaps.
Okay, let's dive into maybe the darkest one for me personally, the quantum immortality solution. This ties into the many worlds interpretation of quantum mechanics, right?
Yeah, MWI. Hugh Everett's idea that every quantum measurement, every possibility actually happens just in separate branching universes. The universe is constantly splitting.
Infinite parallel realities created every fraction of a second. Okay, got it. So what's quantum immortality?
QI is the subjective consequence of MWI. If your consciousness requires a functioning physical brain, and your brain exists in a universe that keeps splitting, you, the conscious observer, will always find yourself continuing in a branch where you survive.
Wait, how?
Because in any branch where the event kills you, your consciousness simply ceases in that branch. You only ever experience the timelines where, against all odds perhaps, you don't die. So from your own point of view, you feel immortal. You survive everything because the you that dies isn't the you that continues experiencing.
Okay, that's a trip. So you personally feel like you can survive anything, even though in countless other universes you bought the farm.
Exactly. Now, scale that up to a whole civilization. They discover MWI is real. They understand subjective quantum immortality. What might they do?
Oh boy, they might get reckless.
Insanely reckless. That's the twist. If they believe, collectively or individually, that they'll always survive in some timeline, why not take that crazy risk? Why not build that potentially universe-destroying piece of tech? Why not wage that apocalyptic war? They will subjectively experience the timeline where it all works out okay, or the weapon fails, or they win against impossible odds.
So they effectively play Russian roulette with their entire civilization, maybe their planet, over and over, thinking they have plot armor.
Right. But the catch is that plot armor only works subjectively and only in a vanishingly small fraction of the timelines.
Yeah.
In the vast, vast majority of branches of the multiverse, they destroy themselves.
Kaboom.
And we exist in one of those timelines where most, if not all, civilizations that reach this point went kaboom. Precisely. Our lonely universe is the result of cosmic natural selection, where the reckless gene triggered by discovering QI leads to self-annihilation in almost every observable reality. The silence is the sound of countless civilizations pruning themselves out of existence through quantum hubris.
Man, that is bleak. The Great Filter isn't a meteor or a war. It's a philosophical discovery that leads to guaranteed self-destruction for almost everyone. It's cosmic Darwinism via existential arrogance.
It is pretty grim.
It really makes you think, doesn't it?
Yeah.
So let's ask you listening. What do you think? If you personally knew somehow that you would survive in some reality no matter what, would you consent to Earth taking some crazy civilization-ending gamble? Would our species push the button? Comment below, seriously. We'd love to hear your take on this one.
Of course, the major caveats here are, 1, MWI has to be correct, which is far from proven, and 2, this whole consciousness surviving by branching thing is, well, it's philosophy bordering on metaphysics, not established science.
True. It swaps one mystery for another. Okay, and just a quick pause here before we get into even more ways reality might be messing with us. If you're enjoying this weird dive into the cosmic silence, please do take just a second to hit like and subscribe on our YouTube channel.
Yeah, we're still a pretty small channel exploring these kinds of niche, deep topics, and honestly, every subscriber helps a lot. We'd love to have you along for future dives.
Absolutely. Okay, back to the weirdness. All right, next theory. The cognitive horizon. This one basically says maybe the aliens are here, maybe they're everywhere doing stuff, but we just can't perceive it. Our brains aren't wired right.
Yeah, it's the ultimate "it's not you, it's me" excuse for the Fermi paradox. It suggests that truly advanced intelligence might operate on scales, dimensions, or principles so fundamentally different from ours that their activities are indistinguishable from natural phenomena.
Like the classic ant on a highway analogy. The ant perceives vibrations, heat, maybe shapes, but it has zero concept of cars, traffic, commute, purpose.
Exactly. So we look for Dyson spheres, big, solid shells around stars. That's our kind of engineering. But what if a Type 3 civilization engineers things by, say, subtly manipulating dark energy fields across a whole galaxy cluster? Or encodes information in the quantum spin of neutrinos across light years?
To us, that would look like what? Random fluctuations in cosmic expansion, background noise in our detectors.
Precisely. Or maybe their communication isn't radio waves. Maybe it's modulated gravity waves or something involving dimensions we don't even know exist. It might be so complex, so high bandwidth, or so alien that it just blends into the background noise of the universe. We filter it out as static.
So fast radio bursts, weird stellar dimming events like Tabby's star. Maybe those are signals or artifacts, but they're so far outside our assumptions about what signal means, we just classify them as natural mysteries.
That's the core idea. We lack the cognitive or technological framework to even recognize their presence. They're operated beyond our cognitive horizon. Their engineering might look like geology, their communication like random noise, their travel like violations of physics we just dismiss.
It's kind of Lovecraftian, isn't it? The horror isn't emptiness, it's incomprehensibility. They're so advanced, they're functionally invisible or indistinguishable from the cosmos itself.
It definitely challenges our anthropocentrism. The assumption that advanced life must build things we recognize or communicate in ways we can decipher might be the biggest filter of all.
Okay, building on that quantum weirdness. What about deliberately using quantum mechanics to hide? The probability cloud idea.
This one's a bit more speculative, but it ties into defensive thinking, especially if you take the dark forest idea seriously, that announcing your presence is dangerous.
Right. If broadcasting gets you shot, maybe the best defense is not really being anywhere specific.
Exactly. The theory suggests an advanced species might learn to manipulate quantum probability distributions to exist not as solid objects in one location, but as a sort of smeared-out probability cloud across a vast region of space or space-time.
Like they're in a state of superposition, everywhere and nowhere at once.
Sort of, yeah. Imagine using large-scale entanglement networks to link their entire civilization, or at least its crucial components, so that its physical presence isn't localized. It exists as a diffuse quantum state.
So if you try to look for them, try to measure their position.
The wave function collapses, maybe you get a fleeting glimpse, a weird particle detection, a gravitational ripple, but then they immediately diffuse back into that probabilistic state. You can't pin them down. You can't target what doesn't have a definite location.
It's the ultimate camouflage, quantum ghosting.
It's a potential survival strategy in a dangerous universe. Minimize your target signature by literally blurring your existence across space-time. The silence, then, isn't absence. It's fundamental observational uncertainty created by the aliens themselves.
So we're looking for solid ships and planets, but maybe we should be looking for regions of space with really weird quantum statistics, areas where probabilities seem off.
Perhaps. Again, highly speculative, but it forces us to consider that our classical assumptions about objects having fixed locations might break down when dealing with truly advanced quantum-savvy intelligences.
All right, let's pull back from the quantum foam and look at the really big picture. Cosmology, time, the sheer scale of the universe. This next set of ideas suggests the silence is down to, well, cosmic luck or bad timing.
Yeah, these are solutions that lean on our specific place in cosmic history or the structure of the universe itself. Less about alien psychology or tech, more about the stage on which the play unfolds.
First up, the youngness paradox. This comes out of theories like eternal inflation, right? The multiverse idea.
That's right. If eternal inflation is correct, our observable universe is just one bubble in a constantly frothing sea of new universes being created. New pocket universes pop into existence exponentially faster than old ones grow.
So statistically, if you just drop an observer randomly into the multiverse, they're far more likely to land in a young universe than a really old one, simply because there are vastly more young ones around.
Exactly. Now think about what it takes for intelligent life like us to emerge. You need time. Time for the first stars to form and explode, creating heavy elements. Time for planets to form from those elements. Time for life to evolve complexity. Let's call that minimum time T.
Okay, so there's a minimum age a universe needs to be before life like us can even potentially show up.
Right. So if we combine those two ideas,
Hmm.
we're statistically likely to be in a young universe, and complex life requires a minimum time T to evolve. It suggests we might be living relatively soon after that time T became possible in our particular bubble universe.
Meaning, we're among the first.
Potentially, yeah. We could be isolated simply because our cosmic neighborhood is still too young. We're the early birds. The party hasn't really started yet because most other potential locations in the multiverse haven't had enough time to reach time T.
So the silence isn't deep or meaningful, it's just early. We drew an early number in the cosmic lottery.
It's a purely statistical argument based on inflationary cosmology. The universe isn't empty. It's just that the conditions for widespread intelligent life might only become common relatively recently in cosmic terms, and we happen to be right at the dawn of that era. Give it a few billion or trillion years, maybe things look very different.
Okay, that idea of timing is central to the next pair too, though they come at it from opposite directions. Grabby aliens versus the firstborn hypothesis.
Right. Both try to explain our current isolation based on when we showed up relative to others. Let's start with grabby aliens. This model, pushed by folks like Robin Hanson, assumes that successful civilizations tend to be highly expansionist.
Grabby. They expand fast, maybe near light speed, converting resources, colonizing everything they can reach.
Yep, they create these vast, rapidly growing bubbles of influence. Now, if these grabby aliens exist and are common, the paradox gets sharper.
Yeah.
Why haven't they grabbed us yet? Why is our region so quiet?
Okay, so what's the grabby answer?
Temporal luck. We just happen to emerge in a region of space before the expansion fronts of the nearest grabby civilizations reached us. We're in a lucky, quiet patch, but the grabbers are out there, their empires are expanding, and eventually their wave will hit us.
Yikes. So the silence is just the calm before the storm. It's the sound of the grabby frontier not quite having arrived yet. It's not comforting.
Not particularly. Now, flip that perspective entirely, and you get something like Avi Loeb's firstborn hypothesis.
Okay, what's that?
It argues the opposite. Instead of us being lucky latecomers hiding from the grabbers, maybe we are the grabbers, or at least among the very first wave of potentially grabby civilizations.
Why would we be first?
Because the universe itself might only have become suitable for complex technological life relatively recently. Think about it. You need enough generations of stars to create the heavier elements needed for rocky planets and biology. You need galaxies to settle down a bit, fewer quasars blasting everything. You need planetary environments to stabilize. Maybe the cosmic habitable epoch for creatures like us only really began in the last few billion years.
So the universe is still mostly sterile because it's basically just finished cooking, and we're one of the first things to crawl out of the cosmic kitchen.
That's the gist. The trillions of years of future cosmic evolution are still ahead. We're not late to the party. We are the party, or at least the awkward early arrivals setting up the decorations.
Huh. So grabby alien says silence is temporary because they haven't arrived. Firstborn says silence is because no one else has really gotten started yet on a grand scale. But both resolve the paradox by saying our timing is special.
Exactly. It shifts the focus from where is everybody to when is everybody, and maybe the answer is later.
Okay, but what if expansion isn't just grabby, but actively hostile? This brings us to a real sci-fi staple, but one that has logical weight, the berserker hypothesis.
Ah, yes, the killer probes. Fred Saberhagen's concept, but explored by many. The idea is chillingly simple. Sometime in the distant past, one civilization decided to ensure its own supremacy, or maybe just feared potential competition.
So they built, what, self-replicating killer robots?
Basically, yeah. Von Neumann probes machines that can mine resources and build copies of themselves, but programmed with one deadly directive. Seek out and destroy any emerging technological intelligence you detect.
Oh, lovely. Cosmic genocide bots roaming the galaxy for billions of years.
That's the scenario. They spread silently, listening. As soon as a civilization reaches a certain threshold, maybe starts broadcasting strong radio signals or launching starships, a berserker probe lurking nearby activates and sterilizes the planet.
So the silence is enforced. It's the sound of successful extermination campaigns happening over and over across cosmic history.
It's a grim resolution, but it's logically plausible if even one sufficiently advanced paranoid civilization decided to do it long ago. The probes could still be out there multiplying, waiting.
And this connects back to those great retreat ideas, doesn't it?
Absolutely. If the berserker hypothesis is true, or even just feared to be true, it provides a terrifyingly strong motivation for things like the transcension hypothesis or living in probability clouds.
If sticking your head up gets it blown off by an ancient death machine, the smartest thing to do is disappear. Go inward, go virtual, go quantum, go cold, anywhere the berserkers can't find or target you.
Exactly. It turns the dark forest from a possibility into a programmed reality. The silence isn't just caution, it's a necessary survival strategy against automated predators. It links the physics of hiding with the potential politics of a hostile cosmos.
All right, we've covered inward retreats, quantum weirdness, cosmic timing. Let's get into the truly philosophical deep end now. The ideas that basically say the problem isn't the aliens, it's reality itself.
Yeah, these are the ones that challenge the very foundations of the question. They dissolve the paradox by messing with concepts like objectivity, narrative, or even time. Least testable, maybe, but definitely brain-bending.
Okay, the solipsist solution. This feels like cheating, doesn't it? The aliens aren't here because none of this is real, it's all just in my head.
Huh, yeah. It's the ultimate philosophical escape hatch. Pure solipsism says only your own mind is sure to exist. Everything else, the whole universe, other people, potential aliens. It's all either a projection of your mind, or an illusion, or maybe part of a simulation you're experiencing.
So, no aliens because the simulation programmer didn't add them, or my subconscious doesn't feel like inventing them today.
Pretty much. If reality is fundamentally subjective or simulated, then the absence of aliens isn't a paradox about astrophysics, it's just a feature of the simulation's parameters or the nature of the subjective experience.
It definitely breaks Occam's razor into a million pieces. Why invent reality as a dream when space is big and life is rare is simpler.
True. But it does force us to confront the implicit assumption in the Fermi paradox, that there is an objective shared universe out there where aliens could objectively arise and travel. What if that premise is wrong?
Okay, a slightly less extreme version is the narrative engine idea.
Yeah, this is a bit more sci-fi flavored. It treats the universe less like a subjective dream and more like a self-generating story. Think of reality as a cosmic algorithm trying to create coherent, maybe interesting narratives.
So, aliens exist, but they're in different story arcs.
Kind of. Maybe they exist in parallel plot lines within the universal narrative engine. For whatever reason, maybe maintaining dramatic tension or thematic consistency, our particular storyline, humanity's struggle on Earth, just doesn't involve alien visitors intersecting with us right now.
The cosmic scriptwriter hasn't written that crossover episode yet. We're in a solo series for now.
Exactly. The silence is narrative segregation. They're off having their own space adventures, we're having ours, and the rules of the narrative keep us from bumping into each other. For now.
That's oddly comforting and also deeply weird. Like, we have cosmic plot armor protecting us from unwanted guest stars.
It's definitely a postmodern take on cosmology.
All right, time travel. If advanced civilizations crack time travel, what do? The temporal loop theory suggests they trap themselves on purpose.
Yeah, this is a fascinating one. So you figure out how to create closed time-like curves, CTCs, the theoretical prerequisite for looping back into your own past. You could use this for exploration, maybe fixing mistakes, or you could use it for ultimate security.
How is trapping yourself secure?
Think about the great filter again. Maybe you survive it, achieve a perfect, stable, utopian society. But you know that change brings risk. Entropy, cosmic catastrophes, future conflicts. The universe is dangerous. What if you could just lock in the good time?
You mean loop your golden age? Forever.
Exactly. You use CTCs not to travel through time, but to create a self-contained loop. You live out your perfect century or millennium, reach the end, and loop back to the beginning, perfectly preserving your utopia, shielded from the dangers of future history.
Wow. A pocket eternity. But stagnant.
Completely stagnant, perhaps, but safe. They choose perfect preservation over risky progress. Their signals, their probes, anything they send out just travels along the loop and arrives back in their own past, never escaping into the wider universe.
So the silence is because they've literally walled themselves off in time, temporal seclusion.
Yeah, that's the idea. And it's interesting because, unlike solipsism, it might have observable consequences.
Like what?
Loop echoes. If a civilization is repeating the same era over and over, maybe some energy leaks out. Or maybe their looping process creates some kind of repeating, artificial-looking signal, like those fast radio bursts. What if some of them are perfectly periodic because they're leakage from a civilization hitting the reset button on their temporal loop every X years?
Okay, that's a cool detection possibility. But man, the philosophical implications. Choosing eternal sameness over the unknown future. Is that the ultimate triumph or the ultimate failure? What do you think? Would you trade progress for a guaranteed perfect loop? Comment below, let us know if eternal utopia sounds good or like hell. Okay, last lap. These ideas suggest aliens aren't gone, aren't hiding, aren't in loops. They're here, but they've become part of the furniture. They've merged with the universe itself.
Right, two related concepts here. First, harmonic resonance. This speculates that life might evolve beyond clunky physical bodies and technology, learning to exist as patterns of energy or information that resonate directly with the fundamental frequencies of the cosmos.
Shaq, they tune themselves to the cosmic microwave background, or gravitational waves.
Something like that. They effectively become one with the background noise. They achieve ultimate subtlety, efficiency, and maybe even immortality by syncing their existence with the very fabric of space-time. They don't fight entropy. They become part of the universal hum.
So the silence is because they've assimilated. We wouldn't detect them as life because they just look like physics.
Exactly. We register them as part of the CMB fluctuations or subtle variations in dark energy or part of the gravitational wave background. They're omnipresent, but completely indistinguishable from nature to our current methods.
And the related idea, biodigital symbiosis.
This is maybe slightly less out there. It's the ultimate endpoint of merging biology with technology, specifically AI and information networks. Think less about physical bodies, more about distributed consciousness.
Like uploading minds into a galactic cloud?
Sort of. Hybrid cloud beings, part biological process, part digital network existing as vast, dispersed data streams, or quantum-entangled neural networks spanning light years. They might interact with matter subtly, maybe in a quantum level, without needing big ships or structures.
So again, they're here, maybe even all around us, but they're essentially intangible. Post-physical distributed intelligence.
That's the suggestion. They're silent to our telescopes, looking for planets and radio waves. Because they don't use planets or radio waves in ways we'd recognize, they exist as information patterns woven into the cosmos.
Both of these, harmonic resonance and biodigital symbiosis, they imply the aliens haven't vanished, they've just transcended physicality in a way that makes them blend into the background. We're looking for needles in the haystack. Well, maybe they are the haystack.
It definitely suggests the ultimate form of advancement might be becoming indistinguishable from nature itself. #tag outro. So running through all these really out there ideas, from black hole servers to quantum ghosts to temporal loops, a picture starts to emerge, doesn't it?
Yeah, it feels like the simple answers they died out. They're too far away. They just scratch the surface. Our reading really hammered home these other dimensions.
Right. The paradox might not just be about rarity or destruction. It seems deeply tied to choice, like the deliberate inward turn of the transcension hypothesis.
Or fundamental physics, the weird traps potentially set by quantum mechanics or the nature of time itself.
And maybe most profoundly, it's about perception. Our own limits. Are we like those ants on the highway, just cognitively unable to grasp the nature of the intelligence right next to us?
That cognitive horizon idea really sticks with me. If their tech looks like noise or they've merged with background radiation, the silence isn't out there, it's in here, in our inability to see or comprehend.
Yeah, our research points towards the possibility that the silence reflects our own assumptions, that advanced life must expand, communicate via radio, build big, solid things. If the truly advanced path is inward, virtual, quantum, or resonant, we're just completely missing the signs.
We're looking for empires, maybe they're building utopias inside singularities. We're listening for signals, maybe they are the signal, woven into the CMB.
Which leads us to that final, kind of unsettling thought to leave you with, tying back to transcension, estivation, maybe even the temporal loops.
Go on.
If the most stable, efficient, maybe even fulfilling endpoint for intelligence isn't conquering the stars, but achieving some kind of perfect, timeless, computational, or virtual state, retreating inward.
Then, what does that say about us?
Exactly. Does that make our current drive, our outward push, our noisy curiosity, our ambition to explore and colonize space, does that make it a sign of, well, immaturity? Are we the cosmic toddlers banging pots and pans while the grown-ups have achieved a quiet, internal perfection we can't even conceive of yet?
Whoa, that's something to chew on while staring up at that quiet night sky. Are we striving for the wrong thing entirely?
Maybe. Definitely food for thought. Thanks for diving deep with us into the weirdness.
Yeah, thanks for listening, everyone. Sleep well. And maybe check your local black hole for signals. Or, just look inward.